Hello everyone, welcome to the fourth Global Challenge judging session of the day. Sorry we're getting started a little bit late. We've been battling with using Hangouts to connect everyone from all around the world. This is an extremely global category we have here with personal impact and compelling visualization. We're going to see up to 7 teams from Baguio, Philippines, Hyderabad, India, Nairobi, Kenya, Istanbul, Turkey, Santiago, Chile, and Asheville and Minneapolis in the US. And we've got with us for this category two judging panels, two judges on our judging panel, both of whom know a fair bit about visualization and creative display of information. So very pleased to have Jan Kiso and Peter Olsen with us. Peter, would you like to introduce yourself briefly?
Sure. I'm Peter Olsen. I'm a director and creative technologist at IDEO in New York, and I'm really happy to be here and really excited to see all of the visualizations of climate change and tools that people put together to help consumers change their behavior and better understand their impact in the world.
Thanks, great to have you with us again.
Peter.
And Jan, who confusingly will be showing up as Ruth, assures us his real name is definitely Jan. Hi. Oh, I've got your sound turned down, I'm sorry. Sorry, you were with your volume turned down there. Hi there.
Does it work now?
Yes, we can hear you now.
Yeah. Thanks. Hi there. I'm Jan Kiese from the Department of Energy and Climate Change, which is the UK ministry looking after energy and climate change issues. I've been working for the last 10 years in this area and have been involved in broader pieces of work around the UK Climate Change Act, which provided legally binding targets for emissions reductions within the UK, and then how the UK intends to achieve these emissions reduction while restructuring its energy and land use system. Over the last 4 to 5 years, I've been quite heavily involved in the development of the 2050 calculator, which is an energy model, open source energy model, which we hope is conducive for people who are non-energy experts to communicate the messages around our challenges in the field of energy and land use. Over the last 2 or 3 years, we've been quite heavily involved in international work as well, because other countries like China and India have picked up, governments over there have picked up this calculator work, and indeed our pitch was sort of got a bit of an interest here as well, to have a more communicative front end for the recent application which we put forward, which is the Global Calculator, which you can get under globalcalculator.org. Thank you very much for all your work, and it's absolutely fantastic to see that it's such an international team working on this, and we really look forward to working with you on this in the future. Thank you.
Thanks, Jan. And you know, the 2050 calculator and the global calculator, I think it's a great example of building a tool that's specific to one geography, one region, and then extending it to apply globally, which is one thing that we really hope for with a lot of the hackathon projects. Obviously, it takes a bit of time and a lot of dedication to make these things happen. So this is just the start for many of these projects, and I look forward to seeing them. So. Namra, if you're ready, I'll hand over to you to introduce yourself and your project.
So, can everybody listen to me?
Yes, we can hear you.
Yeah. So, hi. I am Namra Maheshwari from Hyderabad. We are a group of 3 students from IIIT Hyderabad. We are computer science graduates, and we are pursuing our masters in computational sciences. So GQ is basically quantizing how livable a place is. I mean, what we do is we give a score based on various variables like forestation, nearest vegetation, water bodies, drainage, traffic, etc. And we quantize it to a single score and say that this is your GQ. Let's say your friend live at a different place and you live at a different place. So based on a linear model we have figured out, I'll send you the demo in the presentation. We have calculated a score which, when compared to other somebody else's score, it tells you the higher the score, the more livable the place is. So I'll just send the link of the demo to you. So here is the link, and here's the link to the PPT.
No, but actually, do you want to share your screen and show us? You can show us on screen.
I mean, the problem is the bandwidth is really not that good here. Means I can share the screen, but you wouldn't be able to see much. Means I've already tried that. Means that's why
Okay.
I uploaded it on the OneDrive.
Okay, so just guide us with what you want us to look at.
Yeah. So I've already sent the link. There is a Google link, shortening link.
Yep.
So there is a small 1-minute video on that. It's basically a demo of what we have made.
Or can you listen to
Able
your
to see the video?
The guys just send me over the link.
So should I continue now?
Yes, you've got sort of 30 seconds left to.
Okay, so everybody has seen the video. Now, how do we do it? Given a latitude and longitude, we take the data set. The data set is divided into like grids. I mean, the GIS data set has been divided into 7200 into 7200 of grids, and then for every grid, following data has been given, like forestation, vegetation, water bodies, drainage, etc. Now, what we do is, from the latitude and longitude, we take nearest grids, and we take a radius of 10 kilometer that consists of at least 30 grids. The nearer the grid is, we give more weightage to the near grids and less weightage to the farther grids. And based on these data from the grids, we make a linear model and calculate the score. The second link is the PPT. It's a Google Docs link. There are photos of linear models and everything else in the PPT. So what we do is we take a linear model of, let's say, forestation. We multiply it by some weight which we have calculated using regression modeling. Then for the population and for trees and vegetation, we are also planning to include drainage and transportation, but we are not able to get the transportation data yet. So we are trying to extend the idea for crowdsourcing the transportation. We'll provide a gamification, as you can see in the app. There is an element of gamification in there. So we'll provide points and score based on people providing us transportation data. In that way, we'll be able to get the transportation data too in the future. Right now, climate data is not also included in GQ. In future, we will include the climate data too to make the GQ score more dynamic.
Thank you. Jan, do you have some? Oh, have we still got Jan on? That looks like he's dropped off. Peter, do you have any questions?
Yeah, I mean, I think I'm curious. Can can you go over some of the, briefly touch on some of the data sets again, and how are different data sets weighted against each other? Like, how can you tell whether, say, forestation versus transportation is more important relative to each other?
So basically what we have thought of is that more are the trees in the livable area and more are the water bodies in the livable area, more is the livability condition of the area. And secondly, with the population, more is the population, less is the livability of the area. I mean, the more denser the place is, the less livable it should be. So based on population has been given a score of square, like it's proportional to the square, inversely square proportional to the population, and forestation, vegetation, and water bodies are just fitted linearly into it. These linear calculations have been done on the GIS data already available. I mean, the weight factors have been calculated based on the regression modeling. This is the link of the data set. I'm just sending you. This is GIS data set. Or the whole Earth is divided into a grid of 7200 into 7200. So every grid is 10 kilometers square. Means taken upon all the area in the Earth and divided by all the grids. Now we take every grid as 10 kilometers square. Normalize the vegetation, the water bodies, and the drainage system, and just put it in the regression model to calculate the score.
Okay. And how do you know, so assuming the model is internally consistent, how do you know that it actually translates to something that is more livable? Because it could be just an arbitrary bit of point.
Yeah, exactly. So right now we do not know this, but based on this GeQu score, we are trying to integrate a feedback system to the app too, where people can give feedback that like it's right, means if this is above 1000, or based on the data we get from crowdsourcing, we'll try to get that. Means we are not able to figure out how to represent that it's consistent or not. Means this is just a linear model based on theoretical calculations. That is totally right. So I cannot hear Dan, I think.
Am I the only judge still?
Yeah, that is muted perhaps.
Okay, well, Jan can provide maybe some questions and feedback on the project card. So, shall we move on to the next team? Have you had your main questions sort of answered?
Yeah.
That one for now. Excellent. Okay, so the next one will be local leaf. Niels.
Hey.
Hey.
Can you hear me?
Yes, yes.
Awesome.
Yes, there you are. Hi, you're in Amsterdam? No, Istanbul.
I'm in Istanbul, yeah.
Istanbul. Cool. Sounds like a great event there.
Yeah, it was really good. It was a good weekend.
Awesome.
So I can move to the presentation, do a screen share, and then move to the presentation, I guess.
Yeah, sounds good.
So can everyone see this?
Yeah.
Okay, great. Yeah, so we're Team Local Leaf from Istanbul, Turkey. And we ourselves are an international team because we're not just from Turkey, we're from Egypt, Switzerland, and I'm from the Netherlands. We got together and we basically started brainstorming about what we want to do, and we started thinking about, okay, let's focus on local consumption of local products. And we had long discussions about the complexity of things. So our general approach is to keep it simple in the beginning and then add complexity later. So the main question starts like, where does this bottled water come from? Because in Turkey, a lot of people consume bottled water, and some water is from nearby, and some water really needs to travel a long distance, which doesn't really make sense. So we wanted to provide insight in something as simple as a bottle of water, but from that we get other questions like how much did it travel, what is the impact on the climate, are there any alternatives, and any other climate impact factors. So basically that brought us to, okay, let's unravel this complexity, starting with something simple as the distance a bottle of water travels. But then later on, if we talk to specialists and we bring them on board, we learn about the recycling and the waste of that particular company and the plastic they use. Then we learn maybe about the sustainability of their supply chain, their life cycle assessment scores and such. So we can layer this information on top of the product we have. So we would start with a transport score, then we would add like an ingredient or component score, and as we bring in more experts and more data, we add more factors, we get more accuracy about the climate impact of that one product. So I'm already talking to a couple of people in Turkey because the data availability is not very high, and so we're focusing very on the early stage of awareness creation, and with that we are trying to gather the data and put it into one platform. So I can show you the video. This is a video basically of our product. It's a mobile app, and you can scan the barcode of a bottle of water, and then based on that we show the score of that water and some additional information, maybe some alternative products. We can scan basically any barcode, and if the barcode we scan is not in the system, then we ask our users to add it. And we added our own water, Hek for su, and su is water in Turkish. And you see this is water all the way from Switzerland, so it has a really bad score. So that's basically how we want to start. We want to engage the community. It will be an invite only in the beginning where we talk to the experts and access their know-how as well as the data sets they have access to. And slowly we open up the system, invite people to participate, and the more they participate, the more they level up and the more influence they have based on the reputation they gain. So it's basically an impact, it's a climate impact database.
That's your 3 minutes there.
Okay.
I'm afraid you could perhaps cover a few more things in answering questions as well.
Sure.
And are these slides are they online as well if people want to check them out?
Yeah, absolutely.
Excellent. Jan seems to be dropping on and off, so I guess he's catching bits of this, and hopefully we'll be able to provide some feedback.
Yeah.
He'll also be able to watch the whole video afterwards on YouTube. So it's up to you again, Peter.
The lone gunman here. So I guess long term, what are some of the other factors you think will be impactful in scoring a particular brand of water?
So like it starts with water, but later on we want to add other products. But since we don't have access to the data, we started with water. And so as we will be talking to the experts, they will be able to help us to define the impact factors as well as access the data that is related to that. So it's partially help with the score and partially help with the data. So it could be like transportation, it could be how the water is eventually gets into the bottle, like the production process, waste during the production process, recycling capabilities of the bottle itself. So all these kind of things will be added to the information, and we will also be able to show the depth of this to the people who are basically looking at this information. So they will understand like it's not just the distance; there's much more. So it's also a little bit like education of the complexity of the supply chain and the life cycle of products.
And is it calculating now, like, is it using the user's local, current location to do the distance calculations, or, okay.
Yeah, so you scan, and at the point where you scan, we know the source where the water comes from, and then we say, so this is the distance, and then based on a basic algorithm, we say like there's, for example, we're in Istanbul, and there's water you can buy from Istanbul, but there's water you can buy from across the country. So we would recommend you, hey, you probably didn't know that this brand is actually from Istanbul, and the brand you're looking at needs to travel like 1,000 kilometers to get where you are. Does it make sense? That's like the mindset we try to get to.
Cool. And are there, as it stands, does it also take into account the volume of the bottle and size of the bottle or anything like that, or is all that data that you're planning to add over time?
Yeah, that's definitely data we plan to add over time. Our initial assumption is that if you want to buy a bottle of water, you're probably, what size you want, like a half a liter handheld or a 19 liter for on the water cooler. So in the beginning, it's fairly easy to say like the same product, 19 liters versus 19 liters. This is the distance. But later on, we'll do like volume measuring, and we say like this many bottles fit in a container, and therefore we can say half a liter takes up much more, has much more climate impact versus big gallons jars.
Okay. Cool. Are we at the? How are we for time, Dan?
Yeah, we're back on to the next one. I just want to add a couple points to that before we move on. One thing you might need to model is kind of seasonal variation. So some products have a different carbon footprint depending on the time of the year.
Yeah.
But they probably still have the same barcode.
So
interesting. Yeah,
so that's where we want to interact with the experts, because those are the things we don't want to put in our assumptions. We want to put in the know-how of the domain experts for that.
Yeah. Well, I'm hoping we can connect you with some. I'm sure we can.
That would be great.
Okay. Well, thank you, Niels. Next, we're gonna go on to we see Clario Cathy in Santiago.
Ya.
Hi.
Ya, eso. ¿Ah? Ya, gracias.
Hi, Cathy.
Hi. You hear me?
Yes, we can hear you.
Okay, so I'm gonna share my screen. Hi, I'm Katie, and my partner is Felipe. I'm from Chile. And we built Reciclario. And what is this? So the problem we found is that the recycling is made on an industrial level instead of a low one. So people may have 2 cans in their houses and don't know what to do with them, because those 2 cans wouldn't count on this huge recycle level we're talking about, making people throw to the garbage these things that can actually be reused. So here in Chile, 50% of the total amount of the useful trash is going to dumps, which is translate to 3.6 million tons of useful materials, which means that we don't recycle 271 kilograms of our trash per year. So going back to those 2 cans, recycling them is equal to 6 hours of TV. So what is the solution that we came up with? In order to solve this, we made Reciclario, which is a social network / platform that people can upload or search for homemade recycling projects. So here's the demo. We have here our main page. We can search for the things you have and make them or a wallet. Maybe I want to make a wallet, so this will search all the things you need to make a wallet. This is the profile where you can see your latest projects, and here is the view of the project. We actually making the things that work is new project and my project. The other things are working, and basically that's it. There is any
Can you paste
question?
the link in chat just so
Sorry?
you paste the live demo link into the chat?
Okay. This is here's all the information, and it's the Geeklist.
So how do you incentivize people to actually do some of these projects?
Okay, so I already make them because I like to do the things with my hands, and it's actually a pretty cool thing. I have a wallet made of milk. Well, we have a cotton milk here and a can. So it's kind of pretty cool, and people always ask me, "Oh, where you get it?" or "How do you made it?" So I thought, yeah, I can look for these things on YouTube. There is not a platform where you can actually put all these things together, and you can do it like quickly. You search for the thing you have, and you can have a list of all the things you can do, or you search for the thing you want to make, and you can have all the items you need to make them.
So it's almost like you're giving people a recipe to create the stuff.
Exactly. And they can also share these things. I mean, you have your bucket where you put everything you want at home that you want to work with. So people may ask you, I don't know, oh, I have this piece of plastic and I need that piece of paper, and you might want this piece of plastic, sorry, and we can share, we can exchange it, or I can buy it, or it's a platform where you can. It's a social media, basically. So you share with people, you upload your projects, and you search for projects. So yeah, and here in Chile is a good way to start recycling, because people doesn't have the habit of recycling. So it's kind of a good way to start.
Right, you're using the social pressure and social interactions to create incentives to recycle.
Right.
Okay.
Thanks.
Okay, great. Thank you, Katie. Really good to see. It's really clearly something that you're very passionate about, and an interesting take on incentivizing people to recycling. Next up, we're going to have Richard with My Future Climate. And are there any other teams who have joined us who haven't presented? If you could type in the chat to let us know that you're here as well, please.
Okay, should I take it off then?
Go for it.
Okay, so I'm Richard Barnes, and I'm based in Minnesota, and the other members of my team include Kathleen Thermos, Rebecca Orson, Lee Freilich, Allison Jean-Jacques. What we are interested in doing is trying to provide an interface whereby people can understand the climatic changes that will be taking place in their region. To put this in perspective, I hope screen sharing is difficult, I guess. There we go. To put this in perspective, I have a little map of Minnesota here. And up in the northern part of the state here, you've got one environment, another in the middle, another down here. And as precipitation and temperatures change, these species are going to move around, and the kind of plants that you can farm are going to move as well. So in an effort to make that kind of change accessible to people, we put together My Future Climate. I'm going to bring that up now. I'm going to try at least. Can you still see? Can someone verify that you can see that?
I can see.
Great. Okay, so the idea here is you put in a location of interest to you. So say Minneapolis, where I'm at. But this has been coded generally, so it works anywhere in the world. And you're interested, for whatever reason, maybe you're into land management, maybe you're a policy maker and you're looking at climate mitigation strategies, in what the climate in Minneapolis will be like in 2050. So you can hit this button, and what the software has done on the server side now is to compare a multi-decadal average of the distribution of rainfall and temperature in Minneapolis in the future with every other location on the Earth. And it's highlighted areas that are climatically similar. In this instance, this purple area down here is the most analogous climate to Minneapolis. And as you advance in the future, you see that Minneapolis's future climate is analogous to something that is farther and farther south, an area that is both warmer and wetter. If we go to, say, for example, take a look at Berlin, you see that that temperature is again drifting southwards over time, which is analogous to Berlin warming up. This project uses the global circulation models for its data. I've spoken with forestry management people and people in agriculture yesterday, and there are a few people interested in trying to use it for policy development. It uses a global data set, so it can be accessed from anywhere in the world and provides information about that. Moving forward, obviously I'm looking for a graphic designer to help out with this, because that's not like my forte there. But the back end is pretty solid, and we're also looking hopefully to incorporate additional parameters such as vegetation on top of this, and hopefully as you scroll down the site, the data will be general and accessible to the public, and as you go downwards, become increasingly technical for users that need that level of extra detail. Are there any questions?
So I'm looking at the site in the other window.
Oh, perfect.
So can you briefly touch again on how are the similarities calculated?
So the similarities are calculated using a method that was originally developed by an environmental group at Berkeley and has since been extended at the University of Minnesota. We take an average of temperatures over time, and we compare those to the temperatures during a reference period at a location of interest. And then there's a division by the standard deviation of those temperatures. So if you're living in a place where temperature is varying wildly, then this means that that particular temperature is not of interest in trying to pin down what the future climate is. And we do this for each month through the winter and summer for a multi-decadal period. And that provides a kind of equally weighted input of all of those months and years into the final result, which is a kind of Euclidean metric of distance between the climates.
And the climate is sort of a yearly average, not really taking into account, say, the summers are going to be hotter, or the winter, the seasonal variations are not really considered as part of that.
Since each one of the months of the year, which is the finest degree of resolution you can get on the global climate models, is treated independently, the increasing summer temperatures, if summer temperatures increase and winter temperatures stay steady, that is accounted for in the metric of how climate is changing. So it's more sophisticated than the kind of annual average of which you just spoke.
Right, but I would be curious to see, like, are my summers going to be hotter or my winter's going to be colder, rather than sort of just the similarity, right? That, I mean, I'm just sort of in the future, right, as you get more more granulation. So, like, if I'm in New York and I'm told my summers are going to be like Mississippi, but my winters are going to be like, I don't know, Washington D.C. That adds another layer of context to the presentation.
Yeah, definitely, and the back end is flexible enough to support that kind of thing. It's just, trying to do a presentation amount of time we had.
Yeah, cool.
Thank you for that suggestion.
Great job, Richard. Thank you.
Yeah.
So we have got one more team with us. We've got Patrick from Forecast 2050.
Hi.
So we'll spend the last 5 minutes on you.
Yeah, can you hear me all right?
Yeah, thanks for joining in. Glad you could make it.
Yeah, great. So my name's Patrick Conan. I joined local climate, GIS, and tech experts in Asheville, North Carolina for the Hack Against Catastrophic Climate Change. We address the personal impact challenge with the goal of utilizing public data sets to provide a personalized, localized impact of climate change. In 48 hours, we built a production-ready web app named Forecast 2050. And I'd like to share a video we made to show you how we did it. So can you see this video?
So I think, well, if you're sharing it on YouTube, we'll all have to open up the YouTube.
Hi, I'm sorry. Could you hear me before?
Yeah, we could hear you.
Can you see the video?
So everyone will have to open the YouTube app on the side to see the video. I can see it.
I can do a screen share alternatively. You can see it?
I can see the YouTube app.
Okay, so let me play this now. Okay, can you hear me?
Yeah.
Yes.
Okay, so that's Forecast 2050. We build our app without a centralized database using open source web technologies like AngularJS, JSON, and RESTful APIs along with a Bootstrap-based theme. I'd be happy to answer any questions you have at this time.
Sure. I mean, I think it's interesting to see this and by future climate together because they do similar presentations, or they're different presentations of a similar concept, and I think it'd be interesting to see you two collaborate.
Yeah, absolutely.
So the river basin calculation is all done through open data as well?
Yeah,
so
that's the World Bank Climate API. Will give you future model temperature data by country or by river basin. We chose river basin because we thought it was more relevant for this kind of application.
Okay. And so it's a fairly, so the river basins are fairly coarse calculations. How would you go to the next step to go to slightly more granular ones?
Right. Well, we chose that data set because it was available in an API, so we were able to build a fully functioning app in the limited time frame. But we did discuss getting more higher resolution data from another source or incorporating historical temperature averages. So I think with additional data sets and more time, we could make this even more accurate.
Cool. Yeah, I think it's interesting that you can put together an app like this without even maintaining a database, for the data.
And working collaboratively, it makes the development process easier. It's easier to get more people involved at the same time, so that's why we chose that approach.
Cool.
Yeah, very cool.
All right, well, thank you.
I like the idea of teams collaborating with each other going forwards. I think that that applies to a lot of you. Well, we've seen some great teams with very different approaches. We've seen quite a spectrum of things ranging from personal impact, recycling, and a few different approaches to visualization of impacts. It's been a really good session. Thank you all for sharing. Peter, do you have any final words you want to share for the teams?
Yeah, I think this is really, I think, amazing and inspiring to see the work that has been done and the different variety of approaches that people have taken to raising awareness and making climate change more tangible. I think one of the big challenges in combating climate change is that it's a very difficult thing to get your head around, particularly because it's so slow and incremental. It's hard to feel it on a day-by-day basis, and being able to make that more tangible to people is and show them ways that they can change their behavior is really important in combating it globally. So really great job by all the team. It's really well.
Thanks, Peter, and thank you for all of the insight that you've offered to the teams as well. And to all teams, good luck with continuing your projects. We're here to support you in doing that. Thank you. Next session is in 3 hours' time, ecosystems and nature. We have 4 teams presenting across a variety of topics, from protecting animals to protecting trees and conserving tree species. We'll be joined by experts from Fauna and Flora International, along with one other judge, I think, as well, on a more technology side. So that one's at 2 p.m. BST in 3 hours' time. Thank you all.
Thanks a lot.